3, 2, unité, feu. Décollage.
Since its launch on December the 25th, 2021, aboard an Ariane 5 rocket, James Webb has exceeded all expectations. Despite initial doubts, this ambitious scientific project has become a game-changer in the field of space exploration. By harnessing the power of advanced technology, the premier observatory has opened up a new window into the depths of the universe. Its infrared eyes allow us to peer through the cosmic dust and gas that obscure visible light, providing researchers with unprecedented views of distant galaxies, nebulae, and even exoplanets. The clarity and detail of Webb's images have stunned both scientists and the general public alike. From inexplicably bright galaxies to life on alien planets, and even the potential demise of our standard model of the universe, join us as we James Webb's most terrifying images ever seen in history that wept away many of our preconceptions about the early universe. We now live in a universe that is full of bright objects. On a clear night, one can see thousands of stars with the naked eye. These stars occupy merely a small, nearby part of the Milky Way galaxy. Telescopes reveal a much vaster realm that shines with the light from billions of galaxies. According to our current understanding of cosmology, however, the universe was featureless and dark for a long stretch of its early history. The first stars did not appear until perhaps 100 million years after the Big Bang, and nearly a billion years passed before galaxies proliferated across the cosmos. Astronomers have long wondered, how did this dramatic transition from darkness to light come about? After decades of study, researchers have recently made great strides toward answering this question. Using sophisticated computer simulation techniques, cosmologists have devised models that show how the density fluctuations left over from the Big Bang could have evolved into the first stars. In addition, observations of distant quasars have allowed scientists to probe back in time and catch a glimpse of the final days of the cosmic dark ages. The current models indicate that the first stars were most likely quite massive and luminous, and that their formation was an epochal event that fundamentally changed the universe and its subsequent evolution. These stars altered the dynamics of the cosmos by heating and ionizing the surrounding gases. The earliest stars also produced and dispersed the first heavy elements, paving the way for the eventual formation of solar systems like our own. And the collapse of some of the first stars may have seeded the growth of supermassive black holes that formed in the hearts of galaxies and became the spectacular power sources of quasars. In short, the earliest stars made possible the emergence of the universe that we see today. Everything from galaxies and quasars to planets and people. But if all cosmic history is a book, unfortunately, not all the chapters are visible to us. The cosmic dark ages make up the bulk of the book's missing pages. Imagine reading Shakespeare's Hamlet and skipping some initial scenes. You would transition from someone whispering in the darkness on the battlements of a castle in Denmark to a prince seeing ghosts and stabbing at tapestries. What happened? This is the situation that astronomers are facing. We now possess an excellent description of how it all started. The Big Bang Theory has successfully explained the features of our universe. Just a few numbers, called the cosmological parameters, can fully describe the universe's initial conditions, and decades of observations have confirmed with spectacular precision that cosmic history seems to have begun with a fiery expansion from a single, still mysterious primordial point. But a shadow fell across the universe as matter cooled from its early incandescence, and relatively simple initial conditions advanced into intricate complexity. This is the source of the rift in cosmic history, the darkness where astronomers wander. What's certain is that a few 100 million years after the Big Bang, a blink of an eye in cosmological terms, the Great Shadow began to lift. Enormous clouds of gas collapsed, and stars perhaps hundreds of times heavier than our sun sparked a light, beginning a photonic deluge that, over eons, illuminated the universe. In this brief cosmic period, all the protagonists of our story, including black holes and galaxies, started to peek through from behind the dark curtain of the cosmic stage. The first stars were mostly made of hydrogen and helium, the lightest elements of the periodic table, as heavier elements did not yet exist. As they shined, these stars and their subsequent kin transmuted those light elements into heavier carbon, nitrogen, oxygen, and other elements crucial to the universe as we know it today. These elements, these ashes from early stars, eventually formed everything we observe around us, you and me included. To fully appreciate this milestone in our chronicle of cosmic history, we must fill in the missing pages surrounding it. How did the first stars, black holes, and galaxies form? How big were they? How fast did they grow, and how was their evolution interconnected? How did the cosmic transition from simplicity to complexity lead to at least one world where curious creatures gaze up at the sky in wonder? Without such details from these few but fundamental chapters, our understanding of the universe and our place within it will be forever incomplete. This is the deepest, purest reason why astronomers are seeking sources farther and farther out. Fortunately, we are privileged to live in an era when telescopes of unprecedented power like the James Webb Space Telescope can aid us in this cosmic endeavor. Not long after coming online, James Webb immediately discovered 6 enormous universe-breaker galaxies, containing what seemed to be almost as many stars as the Milky Way, dating to just 500 million years after the Big Bang. The finding caused a stir in the astronomical world, with some scientists suggesting that it had put our current view of galaxy evolution or even our understanding of the universe into doubt. Besides throwing out seeds of potential new crises in astronomy, the telescope also cemented an old one: the Hubble tension. Put simply, the universe is expanding, but depending on where cosmologists look, it's doing so at different rates. In the past, the 2 best experiments to measure the expansion rate were the European Space Agency's Planck satellite, which gave a most likely expansion rate of 67 kilometers per second per megaparsec, and the Hubble Space Telescope, which studied pulsating stars called Cepheids, and found a higher value of 73 kilometers per second per megaparsec. Cosmologists thought this tension might be down to uncertainty, caused by Hubble not distinguishing between Cepheids and background stars, but the Webb telescope snuffed out that hope with a result of 74 kilometers per second per megaparsec. Since then, cosmology has lurched deeper into a crisis that could reveal new physics or even break the standard model. What might resolve it? More measurements by James Webb, of course. An equally puzzling discovery, in a first, the James Webb Telescope may have glimpsed a rare type of star that astronomers aren't even sure exists. These stellar objects, called dark stars, might not have been fueled not by nuclear fusion, but by the self-annihilation of dark matter, the invisible stuff that is thought to make up about 85% of the matter in the universe. The candidate stars seen by James Webb will need more evidence to be confirmed, but if they're real, the finding could change our story of how the first stars formed. What's more, note that there weren't just inexplicably large ancient galaxies on James Webb's list of discoveries this year, but whopping black holes too. The first, Sears 1019, had a mass 10 million times that of our Sun and was found by the James Webb Telescope just 570 million years after the Big Bang, making it the oldest black hole ever spotted at the time of its discovery in April 2023. We say "at the time" because James Webb didn't rest on its laurels. Earlier this month, the telescope discovered an even older massive black hole 440 million years after the universe began. How these gigantic space-time ruptures swelled to such staggering scale so early on is an ongoing mystery. Astrophysicists are currently exploring options that include the black holes being formed from the rapid collapse of giant gas clouds, although they haven't ruled out that some may have been seeded by hypothesized primordial black holes thought to be created moments after, and in some theories even before, the universe began. In another stunning observation, the James Webb Space Telescope has found more thousands of Milky Way lookalikes that shouldn't exist, swarming across the early universe. Shaped like warped vinyls and sporting delicate spiral arms, the Milky Way doppelgangers were found by James Webb more than 10 billion years into the universe's past. During a period when violent galactic mergers were thought to have made an abundance of such fragile galaxies impossible. But Webb's finding revealed that the disk galaxies are 10 times more common in the early universe than astronomers previously thought. The strange discovery joins others made by James Webb that point to a deepening mystery around how large galaxies, and with them the potential for life, first bloomed in our universe. As study co-author Christopher Consolis, a professor of extragalactic astronomy at the University of Manchester, said in the statement, "Using the Hubble Space Telescope, we thought that disk galaxies were almost non-existent until the universe was about 6 billion years old. These new James Webb Space Telescope results push the time these Milky Way-like galaxies form to almost the beginning of the universe. This implies that most stars exist and form within these galaxies, which is changing our complete understanding of how galaxy formation occurs. Based on our results, astronomers must rethink our understanding of the formation of the first galaxies and how galaxy evolution occurred over the past 10 billion years." A quick note. Our own existence in a disk galaxy means that astronomers usually assume they must have good conditions for sparking life. If that's the case, it's possible that life could have started earlier in the universe than first thought. However, not stopped there, James Webb's ultra-powerful eye has also revealed glimpses of completely new, unexplainable objects. After being trained on the Orion Nebula, the Webb telescope found 42 pairs of Jupiter mass binary objects, or jumbios, Jupiter-sized planets drifting through space in pairs, some as far apart from each other as 390 times the distance between Earth and the Sun. The jumbios are too small to be stars, but as they bafflingly exist in pairs, they are unlikely to be rogue planets ejected from solar systems. Their discovery has alerted astronomers to a brand new formation mechanism for planets, or even for failed stars. Notably, while James Webb glimpsed deep space unlike ever before, it caused a stir in the whole scientific community as piercing through dust to find an ancient, ghostly galaxy. Look at this picture. It's a very blurry, highly dust-obscured resident of the cosmos whose name is only a string of numbers and letters. It even sits at a distance so far from Earth that it slips in and out of the watchful eyes of various telescopes. The image captured by the powerful James Webb Space Telescope spotlights galaxy Aztec 71, but what's striking here is that we're seeing Aztec 71 the way it was just 900 million years after the Big Bang. That's when the universe was turning on its very first stars, absolute eons before our solar system was born. The Webb's view of this galaxy as a hazy speck of light is a far cry from many other glorious images of galaxies and galaxy clusters in its repertoire. However, even this smudge holds important lessons for our understanding of the early universe. As study author Jed McKinney of the University of Texas at Austin said in a statement, "The fact that even something that extreme is barely visible in the most sensitive imaging from our newest telescope is so exciting to me. It's potentially telling us there's a whole population of galaxies that have been hiding from us." Elsewhere, James Webb has helped set yet another record. Pointing Webb's sights on a star cluster about 1,000 light-years from Earth, astronomers discovered some unusual objects, the smallest they've ever observed. The smallest of the new objects that we found is likely to be the least massive free-floating brown dwarf that has been observed to date. Say Kevin Luhman, an astronomy professor at Pennsylvania State University who is the lead author of a study documenting the team's findings. Brown dwarfs are one of the most unusual objects in the universe. Many objects we can see in the cosmos are some form of nebula, planet, star, or black hole. But brown dwarfs don't fall into any of these categories. The best way to describe them is star-like. They're not large enough to qualify as a star like our sun, and they're so large that astronomers won't categorize them as a planet. Another name scientists use for them is failed stars. This leaves brown dwarfs in an unusual in-between state that makes them especially interesting for scientists studying one of astronomy's most fundamental questions. One basic question you'll find in every astronomy textbook is, what are the smallest stars? That's what we're trying to answer. On the other hand, we all know that stars and galaxies aren't evenly spread throughout our universe. Instead, they're connected by an enormous cosmic web, a gigantic network of crisscrossing celestial superhighways paved with hydrogen gas and dark matter. Taking shape in the chaotic aftermath of the Big Bang, the web's tendrils formed as clumps from the roiling broth of the young universe, where multiple strands of the web intersected, galaxies eventually formed. Insights into the structure of this web not only give us a glimpse of the chaotic particle interactions that led to a universe existing in the first place, so astronomers using James Webb were stunned when they spotted the earliest strand of this web ever seen, a gassy tendril made of 10 closely packed galaxies spanning more than 3 million light-years in length. The filament formed when the universe was just 830 million years old and is partially wrapped around a bright black hole. By finding more, researchers hope to find answers as to how the very first galaxies formed. Another addition to the Webb telescope's long list of cosmic distance records this year was its discovery of the most distant gravitationally lensed object ever seen, an Einstein ring produced by the warping of light from a distant galaxy around a mysteriously dense foreground galaxy. How distant? A mind-bending 21 billion light-years away, which, given the universe's 13.8 billion years of age, means that the light from the galaxy traveled almost twice that distance due to the cosmos's expansion. Besides making for a very pretty picture, distantly lensed light shows like this could help astronomers to understand the puzzling nature of dark matter, the unseen substance believed to make up 70% of the universe's matter. Another feature of James Webb is its ability to measure a spectrum of the atmospheres of distant exoplanets, a toolkit which enabled it to spot the potential signs of life in alien farts on a Goldilocks water world 120 light-years away. The exoplanet it found, K2 18b, is a sub-Neptune planet weighing in somewhere between the mass of Earth and Neptune, orbiting the habitable zone of a red dwarf star. After taking an atmospheric spectrum, the Supreme Space Observatory found it rich with hydrogen, methane, and carbon dioxide, all chemical markers of a hydrogen-rich Hyson world that is a prime contender for extraterrestrial life. More tantalizing still was the detection of dimethyl sulfide, a cabbage-smelling compound only known to be produced by microscopic algae in Earth's oceans. The researchers want to take more peeks at K2 18b and worlds like it to find further evidence for extraterrestrial life beyond our planet. James Webb has mostly revealed insight into how everything began. But what about our eventual demise? Fear not, or maybe fear away, doommongers. The James Webb Telescope had you covered this year with a spectacular light show from a dying star, a preview into the demise of our solar system. The donut-shaped ring nebula, also known as Messier 57 or M57, is a 2,200 light-years distant corpse of an exploded star, harboring at its center a tiny pinprick of a white dwarf that is the last remaining piece of the star's core. As it reached the end of its life, the star exploded outwards, hurling its innards far and wide to form what looks like a gigantic eye. The explosion likely obliterated or ejected any unfortunate planets in its way, a fate that will similarly befall our own solar system in 5 billion years' time. While the James Webb's primary goal is to produce awesome science, and not just pretty pictures, sometimes the pretty pictures are the awesome science. Case in point, the stunning portrait of NGC 5068, a spiral galaxy sitting about 17 million light-years away. No ordinary galaxy. This one is spouting off new stars at a record pace. A team of astronomers was able to use multiple instruments on board the telescope to capture the galaxy in all its glory. The detailed images help astronomers understand the formation and evolution of stars, including solar systems like our own. It also makes for a fantastic cell phone wallpaper, and like all NASA images, it's publicly available, so help yourself. After all, as you see, NASA's James Webb Space Telescope pushed all our expectations in a variety of ways. Beyond the stunning infrared images, what really has scientists excited are Webb's crisp spectra, the detailed information that can be gleaned from light by the telescope's spectroscopic instruments. Webb's spectra have confirmed the distances of some of the farthest galaxies ever observed and have discovered the earliest, most distant, supermassive black holes. They have identified the compositions of planet atmospheres, or lack thereof, with more detail than ever before, and have narrowed down what kinds of atmospheres may exist on rocky exoplanets for the first time. They also have revealed the chemical makeup of stellar nurseries and protoplanetary disks, detecting water, organic carbon-containing molecules, and more. Already, Webb observations have resulted in hundreds of scientific papers, answering long-standing questions and raising new ones to address with James Webb. The breadth of Webb science is also apparent in its observations of the region of space we are most familiar with, our own solar system. Faint rings of gas giants appear out of the darkness, dotted by moons, while in the background, Webb shows distant galaxies. By comparing detections of water and other molecules in our solar system with those found in the disks of other, much younger planetary systems, Webb is helping to build up clues about our own origins, how Earth became the ideal place for life as we know it. But it's worth noting that Webb's science mission is just getting started. There's so much more to come. We can predict what sort of incremental progress will be made and what present unknowns will be revealed by gaining this information that eludes us at present. But what we can't predict is what's out there that we presently don't have any clues about. We don't know what sorts of remarkable discoveries we'll be able to make simply because we're looking at the universe as we never have before. That's, arguably, the most important piece of doing science, the ability to open up what we call discovery potential. We know some of what's out there, and that's led us to some excellent expectations for what we anticipate that we're going to find. But what about the things that are out there that we presently have no hints of? Until we look, we don't know. Perhaps the search was best summed up by Edwin Hubble, but his sentiments apply precisely to the Webb telescope as well. With increasing distance, our knowledge fades and fades rapidly. Eventually, we reach the dim boundary, the utmost limits of our telescopes. There, we measure shadows, and we search among ghostly errors of measurement for landmarks that are scarcely more substantial. The search will continue. Not until the empirical resources are exhausted need we pass on to the dreamy realms of speculation. The life of the James Webb Space Telescope promises to be an intriguing one and lengthy. The observatory used very little fuel to maneuver itself into its exact target location, and that means there will be extra to allow the telescope to orient itself for far longer than anticipated. Space engineers have calculated James Webb's expected 10-year lifetime could be doubled. According to astronomer Professor Stephen Wilkins of the University of Sussex, In many ways, that is very good news. We will be able to do a lot more science with it now. However, the telescope will decay as the years go by as it is struck by meteorites and cosmic rays. That will slowly degrade its performance, so we should make the most of it while it is operating at near optimum conditions. Nevertheless, I think the most exciting science that will be done by the James Webb Space Telescope concerns exoplanets. We are going to learn so much about the chemistry of their atmospheres and are going to find some very strange and bizarre worlds out there. It is tremendously exciting. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.